Thinking your embedded products are smart enough, let's make them intelligent at the source of the data. Hi guys, this is Kunal, founder of Gettobyte Technologies. We are officially NXP registered partner for enabling the embedded security and AI technologies onto your embedded products like of energy meters or of automotive ECUs right at the source of the data. We work across power, industrial, and automotive domains to bring intelligence directly into your embedded products using the NXP world-class MCUs and MPUs. And in this video, we are going to deep dive into one such framework, NXP Semiconductors Edge AI platform, which is a software framework to turn your sensor data into an Edge AI models without any cloud dependency. So whether you are building your products for smart energy meters, PLCs, IoT gateways, or automotive ECUs, NXP Semiconductors Edge AI platform and the Get2Byte Technologies team can help you make your things faster. So now, without wasting time, let's get into the video to see how to use the NXP eIQ platform for making Edge AI based products and smart intelligence.
So hello and welcome to our tutorial. In this, we'll show you how to use the NXP's eIQ machine learning software tools. In this, you will learn how to import your dataset, train a machine learning model, and run it on the i.mx93 application processor. Whether you are working on image classification, anomaly detection, or sensor fusion, this video will guide you step by step using the eIQ Toolkit and eIQ Portal graphics interface. So let's get started. So in the beginning, I'll give you a brief about what NXP's eIQ software is. So eIQ stands for Edge Intelligence Environment, which is a development environment that simplifies AI/ML on edge devices. It includes toolkits, libraries, optimized runtimes, all designed to work with NXP's application processor, like the i.mx93 series. Let's start by opening the eIQ portal. This is the G this is a GUI-based tool in the eIQ toolkit. eIQ portals allow developers to train, evaluate, and deploy ML models without writing complex code. So this is the home screen of the NXP's eIQ portal, a graphical interface that simplifies the development, deployment, and analysis of machine learning models for edge devices like microcontrollers or microprocessors. So in the top menu bar, we have the plugins. So plugins are responsible to manage and explore additional components that can enhance functionality. Next, we have the remote devices. So the remote devices gives you the details about the configuration and connect to the edge hardware like i.mx RTs, i.mx 8M series, etc. to deploy your models directly. Next, we have the settings, the general settings of the eIQ platform, that gives you the general software preferences, paths, tools, and version setups. Next up, we have the marketplace. Marketplace give you the access for the downloadable ML models, datasets, or plugins provided by the NXP or the community. Now, in the center, we have our main action buttons. The first one is basically the create project that will be used to create a new ML project. Clicking on this will guide you through the project type, hardware target selection, dataset import, and model creation or import. Next up, we have the open project. So if you want to open an existing project, then that you have saved before, it loads all the projects, settings, dataset, model status, etc. Next up, we have the model tool. Model tool generally opens tools related to the model. That is to train a model with custom datasets, evaluate accuracy, optimize models, convert model like in TF Lite or Onyx. Next up, we have the command line that launch the CLI interface for more granular control or to automate tasks useful for scripting or batch training. Next, we have the time series. Specifically for the time series data, example sensor data, use this tool to label time-based data, train anomaly or classification model, view trends or events. And the last, we have the vision deployment that helps in deploying computer vision models that chooses optimized vision model. quantize and convert to deployment format or deploy to NXP Vision toolkits or hardware like i.MX microprocessors. So let's get started by creating the project. So when you click on this drop down, you have two options, that is to import dataset or to create a blank project. We'll start by importing a dataset that I have downloaded from the Google. So just click on it and you can see this window, and this window gives you three options. First one, these three options will define which dataset you want to download. So first one, we have the walk dataset. So walk dataset is used for object detection tasks that requires a .tar file containing two subfolders, that is the annotations with .xml files and JPEG images with .jpg files. Second up, we have our structured folder, which is used for image classification that requires a specific folder structure with train and test subfolder, each containing subfolder named after labels holding corresponding images. And the third, the last one, we have the TensorFlow dataset that lets to directly download and import standard image classification and object detection dataset from TensorFlow's collection using a simple interface. So in this video, we'll stick to the image classification. So we'll be selecting this second part, that is the structure folder. Let's click on it. And then you can see there is an option available by the name of select dataset folder. Just click on it and go to download. This is the folder that will contain our dataset. Select it and then click on import. And I'll just save all this file on my desktop only. Save. Now it will take some time to read all the files and import the dataset to your system. So now, as you can see that the dataset has been uploaded successfully, and on the screen you can see all the images that were there in the dataset can be seen here. So now, so there is this augmentation tool that I'll give you a brief about this. So what augmentation tool does is that it generates variations of existing images by applying transformation like rotation, flipping, cropping, color adjustment, scaling, zooming, adding noise or blurring, and etc. So I'll just show you how it does. So click on it, and here you just have to add the image, and then you have all these options for which you can modify the image. Uh, why do we use this? So why do we use it is that it expands the data set without collecting new data, helps prevent overfitting, that helps to prevent overfitting by introducing variety, makes the model more robust to real-world input variations. In this interface shown, you can select images and then use the augmentation tool button to enhance your training data before proceeding to model the selection or train. So for now, we won't be using this tool. We'll just stick to simply uploading the dataset and then selecting the model. And click on the select model. Then you have three options in selecting the model, that is the classification, segmentation, or the detection. So classification is generally used for that identifies what is in an image. For example, whether it is a cat, a dog, or a car. And we'll use this classification when you only need to label the entire image based on its overall content. Second up, we have segmentation that labels each pixel in the image to identify different regions or objects. The segmentation is generally used for tasks like medical images, scene understanding, or road or lane detection, where precise object boundaries matter. Third up, we have the detection that detects multiple objects in an image and draws bounding boxes around them, giving label and position. It is ideal for real-time object detection, that is detecting pedestrians, cars, faces, camera feed, etc. So in this, we'll be using the image classification method. So we'll just click on it. And next up, we have three methods to choose whether it is performance based, balance based, or the accuracy. So in case of performance, it is the fastest inference that is with lowest latency. It may sacrifice the accuracy of the model, but it is generally used when you are running on microcontrollers or devices with limited resources that need real-time response and where speed is more important than the accuracy. Second up, we have the balance mode, that is which is basically a good compromise between accuracy and performance. That is used when you are targeting embedded system. You want reasonable accuracy and speed without heavily favoring one. Third up, we have the accuracy that gives you the highest possible accuracy. It will be slower as compared to the two methods, but it will give you a high accuracy, and it is used when you need when the accuracy is critical, that is in medical or safety system. So for now, we'll stick to the balance mode only, and then now you have four other options whether to choose the MCU, CPU, GPU, or the NPU. We'll be using the NPU mode. That NPU stands for Neural Processing Unit. It is basically the hardware which is embedded on a microprocessor. In our i.MX93, we have our ARM-based Ethos U65 NPU, and the inference engine that we'll be using, which is the software like the TF Lite, DPURT, which the uses the NPU when appropriate to run the ML model efficiently. So we'll just click on the NPU. And now, so through this window, we will start training our model. In this, it has many options. On the left, you can see that in the trainer settings, first one, we have the input size. So this represents the shape of the input image that will be fed into the neural network. So this 32, 3 defines that the 32 is the basically height of the image, and this 32 is the width of the image in pixels only, and this 3 is defines the number of channel, that is 3 for RGB. It is recommended to use 128, 128, 3 or above for a better model. But for now, we'll sticking to this only because this is just a demonstration video. And as you increase the input size, it will increase the time for the training of the ML model. Next up, the important thing, we have the epoch to train. An epoch is one complete pass through the entire training data set. So here, epoch to train is one. That is, it means that the model will go through the full data set. Increasing this value to 10, 50, or 100 allows the model to learn better over multiple passes through the data. More epochs means better learning to a point, but longer training time. But it has a disadvantage that when there are too many epochs, there is risk of overfitting. So we need to select a balance mode, like let's say 10, 20 epochs to train. So for now, I'll just sticking to epochs to train to one because as I increase its number, it will increase the time for the training model. Other features, we have this learning rate that controls how big each step update is. Here it is just 0.0001. That is each update step is 0.0001, is small and safe. Next up, we have the batch size. That is the number of samples per training step. Then we have the enable QAT, that is quantization aware training for better NPU support, where we have enable pruning or clustering that is used for model optimization like alpha beta pruning and all. So we'll just start with the training and click on it. Again, it will take some time to train the model. So now as you can see, the training of the model has been initiated and it will take some time to train the model. Next up, we have some other options on the left side, that is the augmentation setting. It will be enabled once you click on the augmentation tool. Next up, we have the model parameters that we will discuss in depth about this in our upcoming videos. We have the evaluation settings, model performance, like number, train sets, train step time, train IPS, latency, etc. And in the last, we have the model status that will give you for the total running time, how many pods remaining, the progress, and estimated completed time. And on the main screen, you can see the steps, duration, epochs, duration, and all. So the training progress has reached 100% and now the model has been trained. Now from here on, we'll move to the validate section. Just wait for it till the option appears. So yes, it's done now and we'll just click on the validate. So validating a model means you are calculating its accuracy. So we'll just click on the validate. And again, it will take some time. So now our model has been validated. And as you can see on the screen, there is a confusion matrix. So a confusion matrix is basically a table that is used to evaluate the performance of a classification model. It compares the actual label, the true values with the predicted labels from your model. This green part shows that this class has shown the maximum accuracy in that particular, and this red part shows the minimum accuracy of that particular class. So in the confusion matrix, it has four parts, that is the true positive, false positive, and true negative. I'll explain you each term. The true positive is the mod that means the model correctly predicted positive class. True negative means the model correctly predicted negative class. False positive means the model incorrectly predicted positive class. That is a type 1 error. And fourth one, that is the false negative, is a model incorrectly predicted negative class. That is a type 2 error. So it is useful in visualizing the performance beyond just accuracy. It allows you to calculate the precision, the recall, and the F1 score. Next up, we have the per class metric that will show you the accuracy of each class. And as you can see, this class has the maximum accuracy, and this has the lowest, and this has some total accuracy is very low because we have trained it for a very shorter time for very less number of epochs. That is one only. So now the next one is to deploying the model. So when you just click on the deploy here, you have two methods to deploy the model. First one is deploy the model directly to your microprocessor. A second one, you can export this model file in the whether it is in the DPURT format or TensorFlow Lite Keras, depending on your need, and then just export it, download it, and then store it in the SD card. Then you can put that SD card in that particular microprocessor or the microcontroller to deploy the model. So that's it. That's the end of the video. And thank you so much for watching and stay tuned for our upcoming course on embedded AI and security. Thank you.
So that's it for this video, guys. Now, in this video, we are going to know how to use the eIQ framework and platform for training and generating your AI model corresponding to your specific hardwares, the NXP MCU and NPUs. Now, like in the case, like using the NXP i.MX 90 microprocessors. Now, in the next video, we are going to deploy the trained AI model into the series of i.MX 93 series for running your AI models actually into your MCU or lower MPUs. So till then, stay safe, stay happy, share this video to the maximum people for us to keep the AI technologies enabled by the masses and by the embedded developers and OEMs. Till then, keep engineer and don't be just graduated.